Okay.
Good morning, everyone. This is Jim Baxendale, Director of the Whiteboard Boardroom Program. Welcome to the webinar series that we hold almost monthly. As you can see on the first slide, what we're attempting to do here is to introduce various unique technologies from our partner institutions to entrepreneurs to hopefully start new companies or license them into established companies. There'll be two technologies presented today, about 8 to 10 minute presentations. There will be a few minutes at the end if there are any questions, or if you feel you want to contact us directly after the webinar, that will be fine. First up from the University of Missouri St. Louis, a novel software tool to look at effective project management will be presented by Dr. Lee and Tamara Wilgers from the University of Missouri St. Louis. Dr. Lee has as his areas of research, optimization, modeling, simulation, and algorithm design in terms of optimal scheduling and configuring complex systems. Tamara is the Director of the Office of Technology Commercialization and Economic Development at University of Missouri St. Louis. So Dr. Lee and Tamara, if you'd like to go ahead, I think we're all set.
Sure. Thank you for the introduction, Jim. And we'd like to kind of introduce this new software tool that helps optimize complex industrial projects. So next slide. So what is the problem? Project management optimization needs pretty much work across several different industries. Optimizing resource management, supply chain design, and logistics are essential to keep costs down and keep projects on time or possibly even ahead of schedule. So some of the industries that this can apply to, of course, would be construction, pharmaceuticals. That's okay, Robin. Military, you can read those, but we are, for the underline, is we are going to show some case studies on the construction industry and kind of focus on that for today's discussion. Next. So what are the challenges and opportunities of project management? Complex projects need tools to effectively and efficiently allocate resources. Cost overruns are not uncommon when resources aren't allocated optimally to various project tasks. So resource allocation decisions have a huge impact on finish times and return on revenue, which is a measure of company profitability. Uncertainty in task duration caused by variations in crew productivity is a challenge. And also, as you can see on the slide, difficulty of scheduling payments to meet complex payment terms. Next. So current tools are kind of lacking in project management. They aren't dynamic. They don't provide real-time feedback and other useful functionality, but our software does provide dynamic optimization decision support functionalities that aren't available in current tools. So Haitao Lee, Dr. Haitao Lee is going to talk about the technology itself. So we can go on to the next slide.
Thanks, Tamara. After talking with our industry partners, we understand there is a clear gap in the industry to help them optimize their time cost trade-off decisions specifically, which is a very widely applied approach in project management, especially with the complex payment structure and discounted cash flows in the construction industry. Now, what is innovative about our technology is we develop a sequential and adaptive modeling and solution approach so that we are able to capture the variation of those uncertainties that Tamara mentioned earlier during the solution process to improve project operation efficiency and productivity. And I would also like to highlight that a very important idea and feature of our tool is the fact of that it's data-driven. You know, nowadays it is often not a issue for companies to get data, but many of them are still trying to extract most useful information and decision support out of the data they have. Next slide, please. So here is a very general overview of the modeling and solution process. So it's dynamic and sequential. As you can see, at every stage, we make the current project crashing decision, and then the decision maker, project manager, observe external disturbance about the data. And after that, collecting that data and feeding into the model, we run the model to optimize the subsequent schedule and resource allocation for the project. So this process repeats during the entire project progress. Next slides. So here is an overview of the core of the two, which is an optimization model. It takes the following inputs, including the total project value, make spend due date or deadline, duration and cost of each option, available options for each task or activity, indirect cost, discount rate, and so forth. Now we highlight, process also takes the exogenous data or disturbance during the project execution, which is very important. Now at the core is optimization model formulated as a mixed integer programming model with the objective maximizing the return of revenue. So the outputs of the two generates the optimal set of options chosen for each task, the schedule of project tasks in terms of their starting times, and it certainly delivers a solution with maximized return revenue and with optimized project make spend kind of as a side deliverable. Next slide, please. So R2 is able to help project manager to achieve maximized return on revenue and improve their project operation efficiency. We do on several real-world case studies, and the results are very encouraging. We were able to increase ROR by around 16%, and also cut down the project make spend significantly. And ultimately, the service delivery is improved. Next slide, please.
So the market use, we are talking about construction, but we are able to use, I think this could be used in many different industries, as we mentioned before, but this does optimize the time-cost trade-off decisions with complex payment structure and discounted cash flows, and leverages availability of data to provide data-driven project scheduling and resource distribution solutions. Next slide. So the industry, the overall construction industry is a huge global market. It's estimated at about $10 trillion in 2017. It's anticipated to grow to $15 trillion by 2025. And a little note, on average, 1.1% to 1.6% of a construction firm's operating budget is spent on IT, which actually is considerably lower than other industries, but it's still significant. The project management industry for construction is estimated at about 1.3 billion. That was 2018. It's expected to reach between 1.62 billion and 2.71 billion by 2024. And it's growing at a pretty substantial rate, anywhere between 7.9 and 8.8%. So smaller construction firms, a third use construction software, a third use generic tools such as email or spreadsheets, and 28% cite improved workflow efficiency as their top need or priority. And some of this data is coming from market research feature reports. Next slide.
Yeah, indeed, the numbers Tamara showed you are quite striking and also very encouraging. We did a more in-depth survey of the existing commercial tools for project management in construction from the website called softwareadvice.com. They have a very comprehensive list of the most recommended construction project management software. Certainly on top are those legacy software, Microsoft Project and Primavera. So this table summarizes our findings. So what we find was most of the newer, smaller, software provider, they were able to embed most of the recent advancement in IT, information technology, to make their tool cloud-based, which really make the information flow and data sharing storage seamless and much better than before. But on the other hand, as you can see, many of these softwares are certainly lacking the advanced decision support for project scheduling and resource allocation. Next.
So we have both copyrights and patent rights on this technology. The U.S. national stage application was just filed this month, but the priority date is February of 2017. Next slide. Haitao, do you want to talk about the?
Sure, yeah. We now have a prototype we are very proud of. The prototype is built upon a web-based architecture using the active server page ASP technology, so that the user is able to log in to our server to use the tool without purchasing or install optimization software themselves. And we also had a prototype GUI with database and optimization model all connected into one system. And we implemented a very important feature, we believe, that is to allow different user portal and privilege inside the tool. And as I mentioned earlier, we tested the tool on some small size construction case study. Next slides, please. There are certainly more development to be done. So we are envisioning better design and development of the user interface to enhance user experience and automation of a better workflow for the user. Certainly, to have the tool to be cloud-based, that's scalable and easy to access, to use. We've also been thinking about seamless access of data and exchange with other software if possible. And we still need to do more testing and debugging of the tool. Next slides. A very quick summary. Our tool aims to provide state-of-the-art optimization solutions for complex projects where scheduling and resource allocation decisions need to be made. And our tool is able to deliver better ROR and more efficient completion time project. And again, the tool provides dynamic and adaptive optimization decision support, which is not offered by the other available commercial tool right now. Thank you. Any questions?
Yeah, there have been a couple of questions come in around how would this be used? Would it be used, can it be used in the field by those out on the project, or is it used internally? And then the next one is, you kind of listed maybe some next steps, but I was wondering what are the kind of the timing of all of that in terms of when you would have a marketable product, and what would a strategic partner be helpful in making that happen.
Thanks, Jim, for the question. Yeah, and certainly the audience for the question. Excellent questions. I'll try to answer the first one, and I will leave the second question to Tamara, if it's okay with you.
Sure.
So for the first question, I'd say this tool is primarily developed for project manager. I would say the primary user would be a project manager who needs to plan his or her project upfront. But this can be either done upfront or during the project execution. By upfront, I'm talking about even before the construction company bid for the project. They might need to go through a bidding process. So this tool will be very helpful for the company to better understand the timeline of their project, as well as the budget and resource required for successful project delivery. Now, certainly, as you can see, since our solution approach is dynamic and adaptive, so the tool can be well used, during the project execution process. But I'd say the primary user would be project manager. On the other hand, I like your point on the field use. The field use will be very, very important to provide the data needed. So we may give the tool for a field worker. They may feed in their progress in terms of schedule or cost, so that the tool is able to use those field input data, in the optimization model.
Okay.
Yeah, and so as far as next steps, there is a little bit of development left to go to make this the best tool it can be and most competitive. And I think what we are looking for, and Haitao, please correct me if I'm wrong, but
yeah.
What we are looking for is a commercial partner to work through this next round of development with us. So taking the lead on that with input from the inventors here.
Yes, that's exactly right. The following, the roadmap still needs significant resources and collaboration with industry partners. Yeah, so yeah, we're actively looking for industry partners to work with.
Okay, very good. Don't know if there are any other questions out there at this point. Okay, having heard none, well, Tamara, Dr. Lee, thank you very much. And as the inquiries come in, I'll be sure and forward those on to you. These recorded PowerPoints go out to our entire master list, and we do use them in further marketing. So we're happy to help you with this. So thanks again. Appreciate
Thank you.
Thanks.
Next up, from the University of Missouri Columbia campus, we have a technology addressing food tolerance and flood tolerance and drought resistance in plants. The presenter will be Dr. Sam Bish. He's the current interim director and senior licensing and business development associate in life sciences in the Technology Advancement Office at the University of Missouri Columbia campus. There are 3 research professors that have been involved in this project. Many of them have had distinguished careers in plant genetics and biotechnology. All have worked in this area of genetic mapping of drought tolerance. So with that, Sam, if you'd like to start, thank you.
Thank you, Jim, and thank you, Robin, for the opportunity to present. I think you presented my first slide better than I could have, so that's good to know. But I will just summarize that the 3 inventors that on this technology for this new work at the University of Missouri are Dr. Henry Nguyen, Heng Yi, and Babu Valiuddin, from all major contributors to this technology, which is a new gene trait for flood tolerance and drought resistance, primarily in soybean, but also extendable to other crops. So with that, we'll go to the next slide. I'll be giving sort of the classic introductory pitch, if you will, for a new innovation. What is the problem we're trying to solve? What is our solution? What do we believe the value and competitive advantages of our technology? Some of the applications, an overview of the market for those of you who are not familiar with the soybean market. Where is our current status of our intellectual property? What else is out there that might be competing? Some development. Where is our current development? And some information on those who would be interested in licensing an entrepreneurial path or further collaboration with the inventors. So next slide. So the problem that we're trying to address here is the fact that soybeans are not very tolerant to flooding and waterlogging. So flooding and waterlogging is a stress on soybeans. Obviously, in a non-stress situation, you get high-yielding soybean varieties, but in a flood situation, which if you're in Northwest Missouri, Iowa, or Nebraska in the last summer, you know this is a problem that was right in the forefront of everyone's mind, which is flooding causes lots of stress to soybeans and other crops in the form of damaging the roots, poor nitrogen fixation, accumulation of toxic stuff that prevents yield, and a hotbed for diseases in the plant. So all this combines to lower the yield of a soybean. So that's kind of the major problem. On to the next slide, if we could. Like I said before, soybean is particularly sensitive to this. You put a soybean plant, according to our inventors, you put a soybean plant in a waterlogged situation for just 2 days and you've significantly decreased the yield. And if you're in that waterlogged, flooded situation for a lot longer, which we saw, like I said, in this past summer and not far from where we're at, you get even greater reduction in yield. Another situation that farmers I know think about is, the situation where you have wet followed by wet again, dry. This continuous flood or wet situation followed by drying can create shattering of the soybeans, which is also going to decrease yield. And one of the things I did not know before the inventors informed us of this is that there are very few varieties out there of soybean right now that are even moderately tolerant to this flooding situation. So hopefully I've convinced you that flood stress and flooding on soybeans is a problem that needs to be addressed. So we'll go to the next slide. So what is our solution? Now, what is our inventors' way of trying to tackle this problem? They do a lot of genetic screening, if you will, of soybeans, and they've found this novel gene, novel trait in the soybean plant called the small auxin upregulated protein for flooding tolerance, or the sour FT gene. And they have identified this as a gene that if it's manipulated and confers greater flooding tolerance and waterlogging resistance in plants. And you'd not be able to get a presentation approved by your inventors unless you have some data. So here's the data portion of the presentation up in the upper right of this slide. You can see they have two different lines that they've manipulated to manipulated the sour FT gene, and then if you see in the orange and yellow bars compared to the blue and gray bars respectively, you see that they have increased yield when they waterlog the plants for 4 and 7 days in the plants that have this modified sour FT gene. And since this gene is an auxin related gene, they believe this gene could have importance in other abiotic stresses such as resistance to drought and situations where there's nutrient deficiency. And the reason they believe that is because the main change phenotypically that you see when you manipulate this gene is an increase in what they call the root system architecture, or RSA. You see plants that have more extensive root systems and finer roots and just more, a greater network of roots. So they've done a lot of the testing for the drought for the flooding in the lab, and now have extended it to the field, and I think they're at the lab stage with the drought and nutrient deficiency testing, which we'll see in a later slide. So next slide, please. So what is our value here? I think I've kind of alluded to it. This is a gene trait that in soybeans and hopefully in other crops that will make them more tolerant to abiotic stresses, most notably flooding and waterlogging, drought, nutrient deficiency. Obviously, the goal with any trait is does it help increase yield and not drag the yield, and that is the goal with this technology, is to increase yield of soybeans in stress conditions, but also potentially under non-stress conditions as well. And if that's the case, then that'll help increase soybean production and create better food security as we try to feed the world, or feed the growing population of the world. Next slide, please. So what are some of our potential applications? The inventors envision incorporating this trait into high-value soybean plants, further improving and optimizing the performance of the modified gene with gene editing, such as CRISPR systems. And they believe, I think they found, similar genes or homolog genes in other plants, such as rice, corn, beans, alfalfa, lentils, etc. So they believe this is a gene that can be utilized to create greater resistance to flooding and drought tolerance, not only in soybean, but other crops as well. Next slide, please. Just to give a quick overview here of the market, soybean production is a multi-billion-dollar market that's on the rise. Just looking at the soybean biotech traits value alone was estimated at $13 billion in 2017, and it is rising. So there are market shares available for new traits for soybeans and other crops as we move here through the years. So next slide. For those of you who don't know, just a quick look at where is soybean production most prevalent. The United States is obviously a big player. Brazil, Argentina as well are countries where there's large amounts of soybean production. And then you see others competing countries as well, like China, India, Canada, Paraguay, and others making up the rest of the market. Next slide, please. So as far as our patent status here, we have a pending patent cooperation treaty application. So we have an international patent application that we filed in February of 2019. So in late 2020, we will have the ability to go into the United States and many foreign countries with this application, any country that subscribes to or is a member of the Patent Cooperation Treaty. This technology presents our methods of utilizing the trait, but also the modified versions of the gene itself. So we hope we have some pretty solid protection around this particular trait. Obviously, you can't patent the naturally occurring situation, but we're trying to do what we can around that. Other aspects of this invention besides anything that wouldn't be applicable to Section 101 of U.S. Code of 35 U.S.C. 101. So next slide, please. So there obviously, we're not the only game in town for this type of technology. There are other ways to try to create, optimized resistance to stresses in plants, chemical applications and additives such as synthetic oxins, etc. There are other approaches to try to generate optimized traits for plants. We would say we're here in the genomics, the pink or the purple pinkish area of this right-hand side of the slide, but there are obviously other ways to go about this. But again, there's not a lot of varieties out there that are resistant to waterlogging or tolerant to waterlogging, so we believe we're in a field that may be a little less crowded amongst soybean traits. Next slide. So where are we in the development of this technology? I would say this current summer that we're in right now is a critical summer for this technology. They are trying to take what they've found in the lab for this water tolerance and show that it replicates in the field. That's kind of where we're at, and we're also trying to determine if this trait confers resistance to other abiotic stresses. If that's the case, we'll then continue to optimize the gene modifications, and get this into high-yielding lines. That's the goal, to create commercially relevant lines. So next slide, please. So this is, what are we seeking? Like Jim said earlier, licensing to established companies, or maybe this is an asset that an entrepreneur could be integrating into a biotech, new startup biotech company that has other trade assets. Obviously, there's large field trials that could still be done. There could be trials and work done in other plants. So there's opportunities for partnership and collaboration with the inventors. Last slide. So with that, I say thank you. My contact information is here on the screen. I will take questions, but I will first warn you, I am not the technical expert here. So if there's a technical question that you have that I can't answer, I will not pretend to try to answer it, but instead I can put you in contact with the inventors as needed. So with that, I thank you for your time.
Thank you, Sam. There's been a couple questions come up. One, is there a required regulatory path for this technology? And then could you talk a little bit more in terms of the field testing and what that encompasses? Is it a certain acreage it would need to be done, and maybe that feeds back into any regulatory requirements or submissions that have to be made, so that maybe they tie in a little bit together. But yeah, I'd like to get your comments on that.
Yeah, I'll try the regulatory question first as best I can. In the last few months, I have not been keeping up to date with as much with whether or not, CRISPR edited plants are going to be, how tightly they're going to be regulated. So I think it'll depend on, how strictly, CRISPR, because I feel like that's the flavor of the day for all types of mutations, and is trying to CRISPR them, if you will, rather than doing transgene work. But if it's a transgenic plant, then it's going to go through the normal regulatory process, especially if it's, soybeans for food, it would be, I think, FDA, but also probably some USDA regulations as well. But as far as the field trials, I think they're currently doing just a small field trial. I don't know the level of acreage or what level of acreage would be needed for a regulatory approval. But again, that might be something I would write down here to ask the inventors sort of what they envision as the needs there. But honestly, haven't looked deeply into that. I think we did a market assessment report that may have had some information on that, but I don't have that in front of me. So unfortunately, I'll have to probably give a better answer on maybe a follow-up.
Yeah, okay, that's fine. Are there any other questions from the attendees? Okay, well, as I mentioned earlier to the UMSL team, we will take this recorded presentation, and we'll be forwarding that out to our master list of webinar attendees as well, and be happy to send this on out to others as they inquire kind of in this space. So again, I appreciate it. Very good presentation. Thanks, Sam.
Yeah, happy to take feedback, positive, negative, or otherwise as well, whether, we definitely welcome that. So thank you.
Great. Thanks, Sam.
This concludes our webinar for today. Thank you for attending.